Hello, I'm Deepa Mathur, lecturer in Instrumentation Department, Government Polytechnic College, KOTA. In this video, I will be dealing with a topic, Basic Op-Amp Circuits, which is a unit from the subject Signal Conditioning in Instrumentation for the final year subject, IE308. The first type of basic op-amp circuit that I will be dealing here is an inverter or inverting amplifier. How are we going to use an operational amplifier as an inverting amplifier? So you can see here that there is a triangle here. We designate an operational amplifier by a triangle with a minus and a plus sign. Minus standing for the inverting terminal. That means whatever is given as an input at this terminal will be inverted. And the plus standing for a non-inverting terminal. That means if you give any input at the plus or the non-inverting terminal, that input will not be inverted when you get it at the output. So let's see how this system works. You can see that we have got two resistances, RF standing for the feedback resistance, R1 standing for the input resistance, because we are giving the input voltage V1 through R1 into the inverting terminal, which is used as the input here because the non-inverting terminal is grounded. So we are going to see whether we are going to get an inverted input at the output. So when we try and find out what is the output that we are going to get here, that is the V0, by writing the equation we get that V0 would be equal to RF divided by R1 multiplied by V1. Of course, with a negative sign here because you're giving it through the negative terminal. So when we write the equation, you can see here that V0 will become equal to minus of RF by R1 into V1. But if we consider that RF is equal to R1, then it would get cancelled, and in effect we would get that the output voltage V0 will become equal to minus of V1. That means we have got the output equal to the input, which is inverted, hence because it was given through the inverting terminal. The next basic amplifier circuit we'll be studying here today is the adder, or how are we going to add multiple inputs by using a single op-amp. Okay, so this is not a very different circuit. We have the same kind of a system. Again, the feedback resistance, again the input resistance, again the input voltage, but we just have it more than one time. We've got 1, 2, 3 inputs given through 1, 2, 3 input resistances. So not very difficult. We will continue to write the equation exactly in the same pattern like we did for the inverting amplifier, and you can see that you get RF by R1 into V1 plus again RF by R2 into V2 plus RF by R3 into V3. That is what we have written in this equation here. You see? But you shouldn't forget to put a minus sign here because we are giving it through the inverting input. Again, if you're going to consider that all the resistances are equal, that is RF is equal to R1 is equal to R2 is equal to R3, then they all would get cancelled in this equation, and you'll be left out with V0 will become equal to minus of V1 plus V2 plus V3. So we have accomplished our adder circuit by using an op-amp. Thank you.